Hello everyone. So friends, in our previous lecture we discussed that how to identify a particular problem, that whether it is a dynamic programming problem or not. We saw that dynamic programming has few characteristics. So one of the characteristics which we discussed in our last lecture was optimal substructure. So in this lecture we will see that there is one more characteristic which basically help us to identify that whether a particular problem is a dynamic programming problem or not. So here the other characteristic is overlapping subproblems. So what is overlapping subproblems? So friend, let's suppose we are given a problem and we want to identify that whether the given problem has overlapping subproblems property or not. So we can simply identify the overlapping subproblems property by first taking the problem and breaking it down into smaller subproblems and solving those subproblems to get the solution of main problems. Now what this overlapping subproblems means? So let's say if our solution of a given problem is obtained by solving the same subproblems multiple times. So friends, few lectures back we saw that when we solved the nth Fibonacci number problem using recursion, there we saw that in order to solve the nth Fibonacci number, we first broke it down into smaller subproblems using recursion. And when we were building up the solution back by solving the smaller subproblems, we saw that those smaller subproblems were encountered multiple times. So here the example of calculating the nth Fibonacci number has few subproblems which are overlapping to each other. So here you can see that in one of our previous lecture we calculated the nth Fibonacci number using recursion, and here you can see that in order to solve the fifth Fibonacci number, we broke it down into smaller subproblems, something like this, by using these properties that nth Fibonacci number is equal to n minus 1th Fibonacci number plus n minus 2th Fibonacci number, which is nothing but taking the sum of previous two Fibonacci numbers. So friends, here you can see that when we solve this problem, so in this diagram you can see the boxes which are in blue color are basically the smaller subproblems which have occurred multiple times. So for example, you can see that when we want to calculate the third Fibonacci number, we calculated second Fibonacci number, first Fibonacci number, and again to get the value of second Fibonacci number, we broke it down into smaller subproblems by calculating the fib of 1 and fib of 0. If we see the tree of fib of 3, this much, you can see that we have recalculated this tree here again. And also if you see the tree of fib of 2, which is this much portion, we have recalculated it here and here. And similarly, fib of 1, we have recalculated it here, here and here. And same goes with fib of 0. We have calculated it here, here, here. So friends, here you can see that when we solve this problem by breaking it down into smaller subproblems, we encountered that this problem has multiple overlapping subproblems. Here this same problem overlapped with this subproblem overlapped with this and this. Thus the problem to calculate the nth Fibonacci number has overlapping subproblems. And also friends, you can see that it also has optimal substructure, where we are breaking it down into smaller subproblems and solving those subproblems to get the solution to the main problem. So friend, a problem is considered to be a dynamic programming problem when it follows the two properties, the optimal substructure which we discussed in our last lecture, and overlapping subproblems, which we are discussing now. So friends, in our previous lectures we also discussed that this solution is very less optimized because we are recalculating the values of the subproblems multiple times. So for example, let's say we calculated fib of 3, which has value 2. Now what if I store this value somewhere, and let's say when I encountered fib of 3 again, instead of going to this deep tree, I can just return 2. So I don't have to calculate this tree again. Similarly with fib of 2, if I store the value as 1, I can avoid recalculating this subtree and this subtree. Thus you can see that if I calculate the values in green box once, I can store those values and simply I can reuse whenever these values are required again. Therefore, it's a perfect example of demonstrating that nth Fibonacci number is a dynamic programming problem. So friends, in our next lecture we'll see that how we can store these values somewhere and can reuse them again whenever the same subproblems occurs multiple times. So friends, I hope you like this video. Thanks, have a nice day.